5, trigonometric graphs. We've talked about these graphs basically with algebra as well as trig. You can take the base graph and make a lot of changes with it. One change is for sine, since I have sine up here right now, I'll talk about the 5 critical values for sine. The basic sine function is when it starts at 0, goes to a maximum of 1 and a minimum of -1, and it ends at 2 pi. Okay, so you see there are 2 critical values right there. One cycle around the unit circle is 2 pi. One cycle for a function of sine is also 2 pi. So you always go halfway to get pi, halfway again to get pi over 2, halfway again to get 3 pi over 2. All right, those are your 5 critical values. You pick the zeros, the ones, the zeros, the -1s, and there's your sketch of one. Oh, that's bad. There's your sketch for one cycle of sine. Okay? So 3 pi over 2. That's your one cycle. The A is how far above and below the graph goes from the middle of the graph. Okay? It's how far it goes. So this is A. A is always positive. A is the amplitude. Distance from the axis, i.e. the middle of the graph. Middle of graph. Okay? That's what A does. It's the amplitude. Kind of like an amplifier. You can turn it and you see the boom, boom. You see spikes start going up higher and higher. That's because somebody turned up the amplifier. It's the amplitude. You change that, you change the frequency of the graph. Well, actually the height, the loudness of the graph. I don't keep my equations like this a whole lot. I would never probably do something like this. A sine, I would factor the b out, x minus c over b plus d. So I would change, well, that's how I would look at the graphs. So b is usually what's in parentheses, and that is the number of cycles it completes in 2 pi. Sine right now has a 1 in front of the x, it has a 1 in front of the sine, and it has a 1 in front of the x. That means it completes 1 cycle in 2 pi radians. If I want to find the length of one cycle, that's known as p, the period of the graph. The period of the graph is the length of one cycle. That's the other place you use b. 2 pi divided by b gives you the length of one cycle. One cycle could be from maximum to maximum. It could be from minimum to minimum. Or it could be from start to finish. That's how you know what one cycle is. How do you know one cycle? It's either maximum, maximum, minimum, minimum, or from start to finish. That is one cycle for sine. Okay? What do you mean start to finish? Well, if you graph out one cycle of sine, it goes on and on and on based on your calculator. Okay? It goes on and on. If you're a purist, you would see from here to here, that is one cycle. Some people might consider from here to here as a cycle. That's more like a cosine curve. Those dots are still 2 pi apart. That's the length of one cycle. They're still 2 pi apart. Okay? 2 pi. If you've ever been in the ocean, saw the tides rising and flowing, they use sinusoidal graphs or sines and cosines to map those out all the time. Okay? Phase displacement, where you're starting at. In this one, it's just c over b. In the one below it, it's the opposite of c over b. Why? Because it has a plus sign. So I always look at minus c over b. Your textbook writes it this way. I don't. Okay? I factor it out. That's old school. That's in the old trig books that are about as thick as your graphing calculator because they don't have any pictures, all words. Yes? That's where your starting point, also known as the phase shift. Phase shift, we call it, if it's inside the parentheses, it's going to move the x left and right. If it's outside the parentheses, it's going to move the y up and down. So this is inside the parentheses, so it's going to move the starting points. For instance, if I had, oh gee, I don't know, if I had in black, if I had y equals sine of x minus pi over 2, the whole graph would be shifted to the right pi over 2 units. So it looks something like this. Booyah! The whole graph shifted to the right. That's what putting something inside the parentheses does. Okay? So it shifts it to the right pi over 2. You know, you can put a number in front of this, like a 4. Well, then, I don't know if I can do that with this or not. I'll try. Then all of a sudden, you can start stretching the graph. Is he going to let me? Yeah, that's going to change everything. No. I want to see if I was in a text box, I could do it, but not here, I can't. Stretch it. No, there's no stretching button. Yeah, but that mic moves everything. See? Oh, there is no grabbing point. That's just, yeah, it does too. I did.
You didn't try hard enough.
Ah, baloney. All right, so there's vertical displacement. This affects the y coordinates. D affects the y coordinates. Phase displacement or phase shift, that affects the x coordinates. Your mode must be in radians. You don't graph these out with degrees. You're not solving, you're sketching. You need a minimum of 5 critical values to sketch sine and cosine. You need a minimum of 5 critical values for secant, cosecant, cotangent, tangent as well. So, 2 pi is the length of cycles that are sine, cosine, secant, and cosecant. Okay? It's automatically 2 pi, this equation right here. The length of one cycle is 2 pi over b. Jot that down. That's going to cause you pain and suffering 2 sections from now. At least you can make a note. That the length of one cycle of sine, cosine, secant, and cosecant are all 2 pi in length. The standard, plane, normal variety curves. However, if you go tangent and cotangent, those cycles are only pi in length. Why? Mathematically, that's how they're defined. Cotangent. Pi is the length of one cycle for tangent and cotangent. 2 pi, secant, cosecant, cosine, and sine. All right? The length of one cycle. Okay? However you want to consider one cycle. When you make sketches, you have to make one cycle. Yep, 2 pi. Unless you start changing the numbers, but you know we'll talk about that later. So here's your basic garden variety sine. When I say I'm going to graph out tangent, cotangent, or pi. When I say I'm going to graph out sine, set your calculators up accordingly. 0 to 2 pi is your max and your min. Scale, pi over 2. Negative 2 to 2, scale of 1. This is a different scale than yesterday. The scale yesterday was 1 because I was approximating solutions. Anytime I approximate solutions, I go back to the scale of 1. Anytime I'm sketching a graph, I go to pi over 2. Why? That gives me the 5 critical values. Yep, this is for sine. And it's for cosecant, secant.
Should we have this on our chart?
No, that's going to change. You might come up with a different window that you like. Okay? The 5 critical values I use for pi over 2, and I use negative 2 to 2, scale of 1. So I'm going to put that in my calculator now. And if you have your calculator, get them out, fire them up. You're going to need them. Well, actually, you don't need them. People have been doing this without graphing calculator for a lot longer than they have been doing it with. So, you don't really need it. Window 0 to 2 pi. Scale of pi over 2, pi divided by 2. Negative 2 to 2, and 1. Excellent. Mode, radians. Y equals sine of x. And I go to graph. Ooh, there it is, sine of x. I put negative 2 to 2 on this graph. You can go negative 1 to 1, that's fine. Sine of x. Okay. So, you can see the amplitude is 1. Amplitude equals 1. You can see the 5 critical values. On your sketches, those have to be there. Even if you use a calculator, it's not going to help you find those. You have to know if they are. You have to know this is at pi over 2. What's the sine of 0? Look at this graph. What's the sine of 0? What's y? 0. What's the sine of pi over 2? 1. Sine of pi? 0. Sine of 3 pi over 2? And 2 pi is 0, right? Here's pi over 4. Halfway between? Guess what this number is right here? Oh, square root of 2 over 2. Sine of pi over 4, square root of 2 over 2. Get it? Huh? Nice. Thank you very much. Be here all week. Oh, what about, here's one, 5 pi over 6. Where's that at? Sine of 5 pi over 6 is equal to what? 1/2. They're all there. They're just there in function form, not unit circle form. Why? You can move these functions back and forth, left and right, up and down. You can even flip them over to the x-axis, y-axis. There's a lot more applications of this than unit circle. Unit circle will help us get going. Functions are going to drive us to finish. Now, does anybody know how I'm going to rewrite cosine for my own personal benefit to working with it? Yep, I'm going to factor it out. So I have b times x minus c over b. This is how I look at it. Does anybody know what the a is called? Close. Not amplifier, amplitude. Always positive, it is. You always take the absolute value of it because it's always positive. Amplitude, distance above and below, right here it is a 1. You want to crank it up, turn your amplifier, make it a 5, that's fine. B, number of cycles in 2 pi, or the period equals 2 pi divided by b. That's a more apt approach. This is the phase shift. We've done all these things before with functions. You know, we had the a, f of b, x minus, you know, we had all that for functions. This is just including sine and cosine into the mix. And then D is your vertical displacement. All kinds of words, vertical shift, all kinds of words that mean the same thing. Okay? All right. You ready? Nah, you can graph it if you like, but it's going to look like, yeah. Interesting test question I gave the other day. You see how this looks like a cosine curve if you just look at one cycle. If you continue this on, doesn't starting right here, doesn't that look like a sine curve if you start right there and go? That means if y equals cosine of x, y equals cosine of x, that's the same thing as a sine of x minus, this is pi over 2, pi, 3 pi over 2. You'll get the same curve. Interesting.
So is it useful?
It is useful. Because when I give you a graph and ask you for the equation, you actually have more than one possible answer to write. You actually have an infinite number of answers you could give. Most people stick with a positive cosine graph starting at 0, or a positive sine graph starting at 3 pi over 2. Okay? I'll give you graphs. You give me equations later on. Positive sine, positive cosine. So, on this one, find the amplitude and, let's see, the period for this graph. So, go ahead. And what's the amplitude going to be? Yeah, it is 2. The answer's already up there. Isn't that nice? Yeah, the amplitude is 2. That means it's 2 above and below the x-axis. Now, don't pull a college stunt because you'll get the college reward. There's implied parentheses around the 4 and the x. Your TI has them, okay? The 4x. So that means to see this, to see one cycle on this, if I want to see one cycle or sketch one cycle, I'll go down here. Y equals 4 sine of 2x. If I want to see just one cycle, okay, this is what you have to give me for homework when you make a sketch. First of all, your checklist. 1. Is there a vertical shift, up or down? In other words, what does D equal? Yeah, D equals 0 in this case. So I know the middle of my graph is going to be right here. It didn't move. Coincidentally enough, that's the same as the x-axis. Second thing, your checklist. What is the amplitude? 2. That gives me my maximum. That gives me my minimum. 2, -2. I checked to see if there was a D on here. In other words, was there a vertical shift? And there wasn't. Right. Third on my checklist. All graphs are the same, have the same checklist. What is the starting point? What is the phase shift? In other words, if I want to write this in my way, I'll write y equals 4 sine 2 parentheses x minus what plus 0.
Over 2?
No. Look in the parentheses right here. Is there an x minus anything? No, it starts at 0. Where does sine start at? Up high or on the axis? On the axis right here. So my phase shift means that's my starting point. X equals 0. Okay? And I put a dot right there at 0. Last thing, what is the length of one cycle? What does P equal? And that's what I put right here. What is the length of one cycle? I take 2 pi divided by what number? Right. 2 pi divided by 2, which gives me pi. So far, so good? Pi. Now, I need my 5 critical values. What's halfway between 0 and pi? Pi over 2. What's halfway between 0 and pi over 2? You always go halfway. Because in the problem, it's the number in front of the x. Oh, sorry, it should have been 4. Yep, I miscopied that. Thank you. I did switch them. There, now we're right with the world. 2, 4. 2, 4.
Did we change anything? Or is it...
Not yet. We got the amplitude at 2. No, it's 2. I had it started right. 4 and 2. Amplitude is 2. The only thing I need to change is P. Right, pi over 2. All right. So, that is pi over 2. Okay. Oh, the length of one cycle is pi over 2. So, halfway between that is pi over 4. What's halfway between 0 and pi over 4? Pi over 8. Pi over 8. Halfway between pi over 4 and pi over 2. Add a fourth and a half, what do you get? 3/4 divided by 2 is 3/8. Oh my gosh. You have a calculator if you need it, if you have batteries today. 3 pi over 8. So here's your sketch. 5 critical points. Booyah. Booyah. There you go. There you go. There you go. The biggest complaint is when I impromptu take a grade on your sketching without you knowing it, and I start docking you for not having these. What's the first thing you're going to say? Why do we have to have all that stuff? My response is, I said so to know that you're thoroughly sketching the graphs and just not randomly typing it in. Y equals 2 sine, parentheses, oh, I already got one, 4x. You could type that in and you would not have any idea what that graph is telling you. You would have no idea at all what's being said. However, you do see that there are 1, 2, 3, 4 cycles completed in 2 pi, right? There are 4 sine curves in 2 pi, if you look at it. But I want to see this graph. I want to see 1 cycle. It takes a little bit more work, a little bit more effort. Completely worth it, though. If you want to see 1 cycle, you change your window. Instead of going out to 2 pi, where am I going to? Pi over 2. Second, pi divided by 2. What's each one of my tick marks going to be? Yeah, pi over 8. Pi divided by 8. And then I hit my graph. There's pi over 8, pi over 4, 3 pi over 8, pi over 2. Nice.
But he wants to label all the little.
Yeah, you just label those points. And now you've got, the 5th thing is to connect the dots. Connect the dots. Okay? Fantastic. Because I know there are some of you that are going to try to shortcut this. You're just going to try to type it in, boop, draw a picture. Yeah, I know. My job is to take my big red pen and say no credit. All right? Moving on. Oh, yeah, I'll check the odds, too. I know. College kids, they do it all the time. All right, sketch. I'm going to take this. I'm going to take a picture of it onto another page and work with a clean page. By the amplitude period and sketch the equation. Oh, that's a monster size. Woohoo! Huh? I don't know. I'm just going with it. All right. My administrative assistant knows the first thing on my checklist. What is number 1? You're like a checklist person. What? And what is the vertical shift? There isn't one. So that means the middle of my graph is the x-axis. What do I have to do this? Well, we're at school. We're learning, getting ready for the next week. The rest of this. What is the second thing on my checklist? Amplitude, which is what? Well, 4. Amplitude is always positive. If you weren't chit-chatting so much, you would know that. Oh my gosh, you spun around so many times, not even funny. 4. What? Yep, it's the number right here. Okay. Now, not yet. Okay. You can, that's fine. Once you get the hang of it, you don't have to write this down. You're asking, do you have to write this number 4, that number -4? Yes, you do. Because the scale could change. Good. Check mark number 3. What is the phase shift? Is it going left or right? My starting point. No? See right, so the phase shift is 0. So where does negative cosine start at? High, low, or on the axis? Negative cosine, where does it start at?
On the -4.
Yeah, it starts low. Right there. Well, positive cosine looks like this. It only makes mathematical sense that negative cosine look like that. Or you could have a negative amplitude. The negative still reflects the graph over the x-axis.
The amplitude is absolute value.
I'm sorry? Cosine is an even function. That's only if the negative is inside the angle. Okay? Like the graph of x squared is the same as the graph of negative x squared. They're both parabolas that open up. However, the graph of negative x squared is a parabola that opens down. So it matters what the negative is in relation to the mathematical operations. Nice. Yep. 20. Okay. Moving on. Oh, we got to sketch this out. Oh, what was next? Oh, the length of one cycle. Half hours from start to finish. How do you know that? 2 pies. So if you divide 2 pies in half, how many pies do you have? 4, silly. Jeez. We want high school credit for this class. 2 pi divided by half. Hey, there's always excuses. There's more excuses than
Yeah, I got nothing. I'll just please.
4 pi. What's halfway between 0 and 4 pi? 2 pi. Halfway between that is pi. Halfway between that is 3 pi. So, I connect my dots. Start low.
I like this one.
I do too. There we go. Nice. Nicely done. Questions on that?
Yep.
Connect the dots.
We're all gonna guess.
Questions? All right. We got to question number 8, so we'll go through 9. We'll do this one, and then we'll call it. Find the amplitude, period, phase shift, and sketch the graph. All right? We are. First on my little checklist is, what's the amplitude? Oh, no, yeah, right. What's D? D is 0. So my graph is going, the middle of it, still going to be along the x-axis. So now what's the amplitude? 2. Fantastic. 1, 2. Don't forget those little numbers, -1, -2.
Okay, can we just do
What is the phase shift? Pi over 3. So I'm going to start my graph at pi over 3. If I start my graph at pi over 3, what is the length of one cycle? Oh, sign, positive sign, does it start on the graph, up high, or down low? Or in the middle of the graph? Yeah, on the axis. Okay? Now the question is, what is the length of one cycle? 2 pi divided by 1. That's 2 pi. Oh my gosh. What's 2 pi plus pi over 3? 2 pi over 3. Okay, that'll work. Probably should try to write it as the... how about 7 pi over 3? Would that work? All right, let's do that. 7 pi over 3. You do have a calculator, so I don't feel a bit sorry for you. 7 pi over 3. What's halfway between pi over 3 and 7 pi over 3? 7 plus 1 is 8. 8 pi over 3 divided by 2 is? It is. Divided by 2, yeah. Isn't it 4 pi over 3? 8. Yeah. Yeah, 5 pi. You add them together and divide by 2. 5 pi over 3 divided by 2 is 5 pi over 6. You just add them together and divide by 2. That's another way to find the midpoint. 4, 11 pi over 6. 11 pi over 6. Now, sign. Positive sign starts there, goes up, comes down, hits, goes like this. And this is getting the most out of every day because there's not even close in your textbook. Okay? 11 pi over 6 and half pi over 6, left and right. So go ahead and do, I think we can go through 9, can't we? Without any problems? You can probably go through 15. Try 15. 1 through 15 odd on page what?
426.
426. All right. Sure.
I thought we were gonna do something tricky there. We go start the cosine instead.
No?
Because we had the sine of
All right. Ready? I need to stop this. Nice job. I mean, again.